Morning, folks. When you go for a walk, do you ever stop to think that the whole world is covered by rocks and that every rock used to be different? When you're looking at rocks, you see, you're actually looking at history. All of the rocks in the world used to be melted, or what we call molten rock. This is rock that comes out of volcanoes or gets stuck inside Earth's crust that once used to be melted molten rock, magma. Once this rock comes out of a volcano, gets spewed onto the surface of Earth, then it becomes igneous rock. It crystallizes rapidly, it oxidizes, and it starts to compress the other rocks that it lands on below it. Now, being on Earth as a rock isn't very fun because you typically stay in one place for a very, very long time, but we have processes on this Earth that include wind and water that are constantly going around and over our planet at every moment of the day. And wind and water are the primary agents of weathering and erosion. Weathering is a process where you take these rocks and you break them apart into smaller bits. And then erosion is a process of taking those smaller bits and moving them to a different part on the planet. When these igneous rocks get eroded and get weathered and eroded to a different part of the planet, and other bits of rock start to pile up on top of those bits, and more bits of rock continue to pile up, you get a process called cementation, where you are now creating sedimentary rocks, bits from other rocks turned into a brand new rock. Sedimentary rock could be small bits of rock, can be large bits of rock, or could even be biologic, meaning that it could be parts of shells, skeletons, carapaces, all that type of stuff. But then when you're sitting there and you have become a sedimentary rock, what's going to change you into the next form of rock is the processes of Earth called plate tectonics. We have magma underneath this layer of Earth that we have that are constantly moving. It's like giant wheels that are moving the plates of the surface of our planet along. These wheels are just moving to move all these plates around. And when these plates are moving around, some of them are getting subducted below and turning into magma again. Some of them are being pushed up to form mountain ranges, and some of them are moving side by side to create the earthquakes that we feel here in Southern California. So when they get subducted, they go down below. One section of crust is lighter than the other, and it pushes the other down below. At some point, that will start melting, and it will rejoin the molten rock in the magma, starting the rock cycle once again. So you have metamorphic rock that goes through pressure changes and temperature to change its chemical composition before it gets subducted down, or as it gets subducted down, before it gets melted. If it finds its way back to the surface, if it gets stuck in one of the areas of Earth, inside of Earth, called a sill or a dike, which is a very large open section inside of Earth that typically gets filled with magma, crystallizes, and forms intrusive igneous rock like this, then you can, as a metamorphic rock, you can find your way in there and survive, or you continue to get subducted down below and you get melted and get formed right back into igneous rock, where the process starts again. That is the rock cycle in a nutshell.